चल, let's see beta. In last class what we have seen about the alkyl halides, how alkyl halides are prepared, how they are prepared. So we have seen the preparation of alkyl halides from different methods, and we have done that preparation of alkyl halides. Now today we will see the reaction of alkyl halides. This is more important. So in every chapter of organic, we will try to understand one the preparation, other will be the chemical reactions. So the chemical reactions can be written, can be of different types. So one of the type, so let's discuss types of reactions which we'll see in organic. First type is acid base reaction beta. First type is the acid base reaction. Second type of reaction which we will study are addition reactions. Addition reactions. And a third type of reaction we will study will be substitution reactions. Substitution reactions. And fourth type will be our elimination reaction. Elimination. So in any organic compound, first of all, we need to see from up to down, the priority order is in this. The priority order is in this. First of all, in any reaction it is occurring, we will always check the acid base reaction. Then we will go to addition reaction. Then we will go to substitution. And last priority R should be the elimination reaction. Acid base we all studied in chapter which it was ionic equilibria, what is acid and what is a base. Definition of acid and base we have studied. Three types of acid base. First type was Arrhenius acid base, second type was Lowry Bronsted acid base, and third type was what Lewis acid bases. So these three type of acid base we studied, and when acids and bases react, you all know it gives us what? Salt plus water. And salt plus water it should give, and you should see in the reaction, first acid base reaction should occur. Then we have addition reaction. We all have studied addition reaction in alkenes. And yesterday only we have studied addition, let's say HBr or Cl2 addition on alkene, on alkynes. These all addition reaction we have studied. Next, today we will study about substitution and elimination reactions. And so what is substitution? By its name, it's suggesting you have to substitute one thing in, and elimination is removing some substrate out of your thing. And eliminate the substrate, eliminate the leaving groups, nikale bahar. So these things we will study in reaction of alkyl halides today. So firstly we will start with our substitution and elimination. देखते हैं. So पहले देखें, let's say I have this substrate in which I have this group CH3, CH2 and Cl, है ना? So let's say I have this group. In this I put any nucleophile, any electron loving or electron rich nucleophile, let's say Y negative. Let's say Y negative is acting as a nucleophile. I put in this alkyl halide. In this alkyl halides, we will today study the alkyl halides reaction. How this alkyl halide with chlorine is reacting with any attacking reagent. So if this nucleophile goes and attacks at this carbon and remove this chlorine from here. So what it does? यहाँ से इसने CH2, one hydrogen here also, this CH2, and what it does, nucleophile goes, this Y negative goes, this Y negative as nucleophile goes and attacks the carbon and removes the Cl from here, है ना? तो ये क्या किया, एक one nucleophile has replaced one chlorine from here. One nucleophile has replaced one other nucleophile from here, and this only is known as substitution reactions. Substitution reactions. मतलब one nucleophile has substituted the other nucleophile. एक ने दूसरे को हटा दिया. Strong one always will remove the weak ones. Strong nucleophiles will remove the weak nucleophiles. Other thing also Y negative can do, if Y negative can go and attack, if Y negative can go, if this Y negative can go and attack this hydrogen, take this hydrogen, है ना, if goes and takes this hydrogen, because hydrogen being del positive, यहाँ पर ये del positive है, तो ये वाला इलेक्ट्रॉन will be shifted towards this side, this bond, और यहाँ पर we will make CH double bond CH2, and this Cl will be removed from here. So what Y negative will do? Y negative will take hydrogen from the adjacent carbon, उसके साथ वाले कार्बन से, ये बीटा, दिस इज अल्फा कार्बन, दिस इज बीटा कार्बन, है ना. वाई अल्फा? बिकॉज इट इज अटैच टू क्लोरीन, फर्स्ट कार्बन अल्फा, सेकंड कार्बन बीटा, है ना. सो इसने गया, इसने बीटा पे, द हाइड्रोजन ऑन बीटा ही हैज टेकन एंड ही मेड डबल बॉन्ड हियर एंड रिमूव द क्लोरीन फ्रॉम हियर, धक्का मार के, है ना. सो यहाँ से, सो हियर इफ Y negative is taking up the hydrogen here, Y negative is called to be a base. It is called to be a base, and these reactions are called to be what? Elimination reactions. Because we are eliminating Y with H and Cl minus. Cl minus goes away and H and Y goes away. Understanding or not? So these two reactions you should always remember ki in which this nucleophile, this Y negative is acting as a nucleophile and this Y negative is acting as a base. है ना? In these two, if Y negative is acting as a base, it will do elimination. It will do elimination. How it will do elimination? It will attack the beta hydrogen. It will attack the beta hydrogen, make the double bond. Alkenes made from alkyl halides, remove the Cl minus. It will do elimination. And if this nucleophile attacks on the carbon directly, removes the chlorine, this is only known as substitution reaction. है ना? So difference between substitution and elimination you will come to know. Let's take one example. I will tell you with an example. I also learned from this example. Let's say example, if I take, देखते हैं. Example, if I take, let's say I have CH3, CH2, Cl. Simple this alkyl halide, है ना, इसको क्या कहते हैं हम लोग? This is 1 2, है ना, मिथ इथ 1 क्लोरोइथ, क्लोरोप्रोपेन, क्लोरोइथेन, है ना, दिस इज व्हाट? क्लोरोइथेन. और क्लोरोइथेन में if I put in this first reaction, if I put in this OH minus, means if I put in this reaction KOH plus water in aqueous medium, है ना, water डाला मतलब aqueous medium में डाला KOH के साथ, है ना. तो इफ KOH के साथ में हम, अगर हम लोगों ने aqueous medium में डाला है, so what will happen here? K positive and O minus will come, and O minus will come and attack on carbon and remove the chlorine from it, है ना. This is known as CH3, CH2, and O minus will come and make OH here. This is known as what? Nucleophilic substitution. Nucleophilic, because nucleophile is going to substitute. Nucleophile is going to substitute at this carbon, this nucleophile OH minus. So this is known as nucleophilic substitution reaction. But if in the reaction it is written alcoholic KOH, alcoholic KOH, this means what they have given? They have given KOH and they have given one alcohol, let's say C2H5OH, ethanol. So ये दोनों react करके क्या बनाते? This is base, this will act as an acid, और यहाँ पर ये salt बनाते. So this salt will act as a base. This salt will act as a base, C2H5O minus. ये C2H5O minus will go, and this O minus will go and takes the hydrogen of this. takes the hydrogen of this. अगर यहाँ से इसने इसका हाइड्रोजन ले लिया, so what will it do? इसका हाइड्रोजन लेके इसका अल्फा सॉरी इसका बीटा वाला हाइड्रोजन लेना, इसका बीटा वाला हाइड्रोजन लेना, इसका this hydrogen it has taken, let's say this hydrogen was there, just a minute, let's say this hydrogen was there, so ये इसके salt ने which is acting as a base, it will take the hydrogen of this and will make double bond here and remove the chlorine. अगर ये किया तो इसने यहाँ पर it makes here CH2 double bond which is known as alkene, है ना. So once alkene are made, so these reactions are called elimination reaction. Elimination reaction. So always remember, whenever we are attacking a nucleophile, it will attack on carbon to remove Cl. But if we are attacking any base, strong base, if you are using alcoholic KOH in the reaction, so what will happen? Elimination will happen and alkene you have to form. And alkene you have to form. Now you can see from here. Sure. Okay, beta, don't worry. So again, repetition of this I am going to teach. एक बारी और देखते हैं. Let's say we have same example I am taking. वही वाला. Let's say we have CH3, CH2, Cl, and if I put in this reaction KOH with water, means aqueous KOH. It will be written aqueous KOH. So what will happen in aqueous KOH? Substitution will happen. सब्स्टिट्यूशन होगा यहाँ पे, और सब्स्टिट्यूट करके OH माइनस विल सब्स्टिट्यूट द Cl to give us the result CH3 CH2OH. Therefore from alkyl halide we will get our alcohol. From alkyl halide we will get our alcohol. But if in the reaction it is written alcoholic KOH, this means whenever we have alcoholic KOH, we will have to do the elimination reaction. अगर elimination होता तो यहाँ पर OH minus will attack on the beta hydrogen of the carbon and will make double bond and remove the Cl minus. तो यहाँ पर they will make CH2 double bond CH2. Understanding or not? So you should know which conditions are given in the reaction, which reagent is given. You have to do substitution or you have to do elimination. Here KOH is acting as a base. He is taking the H positive of the carbon. But here KOH is acting as a nucleophile. यहाँ पर KOH as a nucleophile it is acting. देखें, you can see. Yeah. Can you see? So simple it is. Write this in your copy. I'll give you 1 minute. But I will take your questions. Write in the chat box one by one. I will take your question in the last. Write anything if you want to know in the chat. This only write, beta. Sai Pranit, this only right. Don't worry about up. I'm unlocking the meeting for 2 minutes. If someone wants to join, they can join. Beta, once I complete the thing, then you can ask any doubt, beta. Once I complete the thing, you can mark question mark there. Wherever you have doubt, you can write a small question there in your own handwriting. And then you can ask me later. You can message me or you can ask me later. Don't worry. First, understand the things. You will come to know once whole picture is shown to you. You will come to know the whole picture. Small thing may doubt. It is very difficult to tell bit. Small doubts are bit of no use. First, you understand the whole concept. Then you will come to know. So simple it is beta. Whenever we have an alkyl halide, and if in an alkyl halide, if I put in that alkyl halide any KOH, any base, KOH or any OH beta, any base, any base with OH minus, any base, NaOH, KOH, barium hydroxide, aluminum hydroxide, these are all bases. If I put in that any basis, so this OH minus will act as a nucleophile and will attack on where the carbon. If it is attacking on the carbon, it is called to be what? It is called to be substitution reaction. If it is attacking on, if it is attacking on any beta hydrogen, if it is taking beta hydrogen from here, this is alpha, this is beta hydrogens of this. So it will do elimination reaction and it will make alkene. This always remember. Done? So one by one we will study beta. One by one we will study one of things. So let's say we will take nucleophilic substitution reaction today. So I will teach you today all the substitution reaction which we have in our syllabus. So what will happen? Any nucleophile will come and will attack on the carbon atom, and this is known as leaving group. Lg is known as leaving group. So let's say we take an example. OH minus comes, will attack on the carbon atom and remove the I minus from here. And will remove the I minus from here, and this only is known as nucleophilic substitution reaction. This only is known as nucleophilic substitution reaction. So this nucleophile is a Lewis base that donates a lone pair to the substrate. And nucleophiles are electron rich, they will donate the lone pair towards the substrate. This R is acting as, R is what? Substrate. R is what? Substrate. This R is a substrate, and the leaving group, this Lg is known as leaving group because he is leaving from the substrate. One is coming, other is leaving. One nucleophile is removing the other nucleophile. So this nucleophile will make a bond with R, and the leaving group will leave with its own electrons. Leaving group gains electrons, pair of electrons, therefore bonded in the substrate. So they will, I will go as I minus. OH minus will come, attack on carbon, and I minus will go. So from this CH3I, iodo, methane, they converted to methanol, CH3OH. So from iodomethane, they converted to methanol in this reaction. So these three terms you should know. What is a nucleophile? What is a substrate? What is a nucleophile? What is a substrate? And what is a leaving group? What is a substrate? What is an? So nucleophile is the one which is a Lewis base that denotes electron pair to the substrate. And a nucleophile will donate electrons pair to the substrate R, which is acting as a substrate. यहाँ पर attack होगा, and one which is leaving from the R is known as the leaving group. है ना? So always remember, a strong nucleophile will come and remove the weak leaving group. Weak, है ना? मतलब strong leaving group जो जितना ज़्यादा weak है, leaving group is not that much strong to make a bond here. So strong one will come and will make a bond with nucleophile. So R and nucleophile bond will be more strong in comparison to R and leaving group bond. Understanding or not? So let's say we take an example in which we have CH3O minus. This CH3O minus methoxide ion will come and will attack this carbon and remove Br minus. है ना? So यहाँ पर इसने they had made what? They had made ether. Ether. Similarly here, see, I minus will come and will attack the carbon of this atom with chlorine and remove the chlorine minus. These arrows are very important, beta. How I am drawing the arrows? These arrows tells us that how electron movement is going through. Similarly, we have this tertiary amine that will attack on the carbon to remove I minus. है ना? सो इसने यहाँ पर ये quaternary salt बनाया नाइट्रोजन का. quaternary 1 2 3 4 carbons with nitrogen is known as quaternary salt, because this positive and I minus will be in a salt, है ना? Positive or I minus, cation and anion, it will be a salt. So these are some examples of nucleophilic substitution reaction. You should know what is a nucleophile, what is a substrate, and which is the leaving group in the reaction. है ना? Sorry बेटा. देखिए. So one example only, see. Let's say question I am giving you. Let's say I have CH3, CH2, Cl, and I am reacting this with, let's say, NaOH. So the product will be CH3, CH2OH plus NaCl. Understanding or not? If I am using aqueous NaOH from here and I am doing, so in this reaction, you have to tell which is the nucleophile, which is the substrate, and which is the nucleophile, which is the substrate, and which is the leaving group. Write all the answers. That only I am telling beta how KOH will act as a nucleophile or base. That only I am telling you. If we have KOH with water, it will act as a nucleophile. It will do substitution reaction. If we have KOH with alcohol, so it will act as a base. Sure. Simple it is. Now see the answer. See. Nucleophile from here will be OH minus, because OH minus will go attack on carbon and remove the Cl minus. Substrate will be CH3, CH2. This will be substrate on which leaving group is attached. And leaving group is Cl minus is the leaving group. Because Cl minus goes, and Na positive which was remaining, it will come with Cl minus to give NaCl. So this nucleophilic substitution reaction are best for changing from alkyl halides to alcohols. In previous class, we have studied from alcohol to alkyl halides using Lucas reagent, SOCl2. We have Lucas reagent like concentrated HCl, ZnCl2, all those. But in this class, we will study what? Alkyl halides to alcohols. Then write this example in your copy, beta. Write this example in your copy. One more beta question solve. Let's say this one. This question solve beta. Answer I also have shown to you. See, write in which of the following net reaction design the nucleophile substrate and leaving group in each reactions. So let's say first reaction we take. ये वाले में we have alkyl halide and we have a nucleophile with S minus. So this S minus will go attack on carbon and remove I minus from here, and this S minus will combine with CH3. This is our nucleophile, this is our substrate, and I minus is the leaving group. Similarly, let's say we have this acetanilide. यहाँ पर एक alkyne group है with negative with positive salt of this minus will go and attack on carbon to remove iodine from here. And this minus will go and attack on carbon to remove iodine. Last third one also see. So this nitrogen which will act as a nucleophile, it will go and attack on this carbon of the bromine. ये अल्फा कार्बन पे अटैक करके ब्रोमीन को निकाल देता और यहाँ पर ये NH3 it will form, but one hydrogen will come out and will give you NH4 positive and here. So it will make what here? It will make here amines. From here it will make amines. And amine बनाया. So this nucleophilic substitution reaction will help us to substitute these nucleophiles on any substrate and remove the leaving group. Remove the leaving group. And yes, strong ones will come and remove the weak ones. So all alkyl halides like iodine, bromine will be removed by strong nucleophiles. And I will tell you which one will remove whom. Don't worry. Chale. So these three examples you can write in your copy. These three examples write in your copy. I will tell you. I'll give you the notes, beta. Don't worry. Leave space if you have. Leave space. I will give you the notes. Leave the space. I will give you the time to write, beta. Don't worry. Very less. Beta, those who have not joined, tell them to join, beta. I have opened the meeting for 5 minutes. चलें, let's go forward. These all reactions are known as what? Nucleophilic substitution reaction. Nucleophilic substitution reactions. और इसको मैं प्यार से बोलते SN reaction. SN. Substitution nucleophilic. Nucleophilic substitution reaction are known as SN reactions. SN reactions. चलें? Should we start? Don't worry, beta, you will get the notes. Sure. चलें. So see beta, in nucleophilic substitution reactions, we will study nucleophilic substitution reactions. In nucleophilic substitution reactions, what we will study beta, देखें. So see beta, these nucleophilic substitution reactions are of 3 types. So first type is known as, इसको हम लोग प्यार से SN भी कहते. So first type is known as SN1, another type is SN2, and the third type is SNI. है ना? So इसको कहते हैं क्या? Unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution. This is known as bimolecular. You will understand what is unimolecular, bimolecular, nucleophilic substitution. And last is this nucleophilic substitution. Nucleophilic substitution with inversion. This I stand for inversion. This 2 stand for bimolecular. This 1 stand for unimolecular. So we will understand the reaction mechanism of this, how the reaction is occurring, कैसे हो रहा है, by this steps. चले one by one we will try to cover. So today we will study SN2 reaction. आज हम SN2 reaction पढ़ेंगे. देखते हैं. देखें, so today's our topic will be SN2 react. देखें, so beta what happens in SN2 reaction? We will see, देखें, what is SN2 reaction. So this is also known as what, let's say we take example CH3Br and we have OH minus here. So OH minus will go and attack on carbon and remove the Br minus. So यहाँ पर CH3OH will be made and Br minus will be removed as what? Leaving group. This is our what? Substrate. This is our what? Substrate. This is our substrate. OH minus is acting as a nucleophile. है ना? This is our product. See. है ना? This is which reaction? SN2 reaction. This is SN2 reaction. See, so the rate of this reaction, we will write rate of this reaction is equals to K times concentration of substrate into concentration of nucleophile. See, means rate is equals to K times substrate is, let's say, CH3Br and nucleophile is what? OH. So from this only we will come to know that order of the reaction. We will understand what is rate and order in chemical kinetics of your next chapter. Sir will teach you chemical kinetics. So rate is how much fast the reaction is going and how much fast reaction is proceeding in a chemical reaction में कितना धीरे या कितना तेज reaction चल रहा है. For that we write the rate of the reaction. Rate law. This is given by rate law. We will write the rate of the reaction ROR. And we will write the rate of reaction ROR by this. So rate of the reaction will be dependent upon K. K is rate constant. K is rate constant into concentration of alkyl halide CH3Br into concentration of OH minus. So when we add the powers of all the concentration, we will get the order of the reaction. Order of the reaction. Mean how many molecules are actually participating in the reaction. Based upon that we write the order of the reaction. We will come to know the order of the reaction. So this is second order. So this SN2 reactions are second order. So order of this SN2 reactions are 2. And SN2 को हम क्या कहते हैं? Bimolecular. Why bimolecular? Because two molecules are acting together. यहाँ पर इसके साथ ये रिएक्ट कर रहा है. So bimolecular nucleophilic substitution. Bimolecular nucleophilic substitution reaction. इसी को हम कहते हैं SN2 reaction. है ना? So whenever we have given this substrate nucleophile. Let's say I have, let's say, small round bottom flask. Round bottom flask I have. And I take in this round bottom flask CH3Br and I put from above KOH, aqueous KOH. And OH minus I put from above. And so if I increase the concentration of KOH by doubling, if I increase the concentration of KOH by doubling it, the reaction rate, kitna fast it is going, will also double. So if I am increasing the concentration of OH minus, so the reaction rate will also double. If I am doubling this, rate will also double. If I am tripling this, rate will also triple. So similarly, if I am doubling the concentration of CH3Br, by doubling the concentration of CH3Br, my rate will also double. My rate will also double. So anything which is dependent upon concentration will be shown in the rate of that reaction. Will be shown in the rate of that reaction. So this is what SN2 reaction. So now we will understand how this SN2 reaction occurs and what is the mechanism of the reaction. Write this all beta in your copy. SN2 reaction के बारे में लिख लें. Write this all in your copy. And then we will understand the mechanism of the reaction. Write fast beta, I won't give you time to write. Beta, KOH is in SN reaction, KOH will always act as a nucleophile. We will never talk about base in substitution reaction. SN reaction, KOH is acting as a nucleophile. So beta, I have logged the meeting. Beta, if you are taking this seriously, please take all the lectures seriously. This is for you only. These all lectures are for you. This is for your preparation only. We are not here for just enjoyment. Take this seriously. Don't miss any lecture. Most importantly, if you are missing any lecture, you won't get it again. What if we leave accidentally? If you leave accidentally, beta, you can leave. No worry. See the video, see the recorded video if you have left in between. See the recorded video and complete your notes bit. Chale? Everyone has written. Should we proceed further? आगे चले? चले. So let's say we tried the mechanism of the reaction SN2. So what happens in this mechanism? This reaction, let's say we have in this. See, this OH minus will attack, let's say this carbon, this 3 hydrogen it has, this H and this chlorine is in the plane. This H and this chlorine are, this H and this chlorine are in the plane. है ना? अगर ये दोनों in the plane है, if these two are in the plane, if these two are in the plane, sorry. If these two are in the plane, if this H and Cl are in the plane of the reaction, this OH minus will come and attack from backside. It will attack from backside this orbital, which will be the sigma anti-bonding molecular orbital. This orbital. So C has two orbitals. One is the bonding molecular orbital of CCl, and this is the sigma anti-bonding molecular orbital, which is empty. So it will attack at the empty sigma bonding molecular orbital and will donate its electron towards it. So क्या होता है? This negative hydroxide brings a pair of electron to the partially positive carbon from backside. It is coming from backside with respect to the leaving group. So leaving group is going from this front side and OH minus should come from backside attack. This chlorine minus begins to move away. So what happens? This chlorine will try to move and this bond will try to break. This bond will try to break of C chlorine and new bond of OH and OH and carbon will be making in this. So this is known as what? Transition state. This is known as what? Transition state. So जो state where carbon is making pentavalent. See here. So carbon is here pentavalent. Pentavalent. And a carbon is here what? Pentavalent state. Carbon can't make 5 bonds, but this is the transition state where carbon एक side पे bond को तोड़ रहा है और next side it is making a new bond, and on the other side it is making a new bond, है ना? तो यहाँ पर one side bond breaking is also happening and one side bond making is happening, है ना? If both the things are happening simultaneously, this is known as transition state of a reaction, है ना? So from here OH will come and will combine with the carbon, and this hydrogen which was towards this side in the starting, and it will shift to opposite side. It will shift to opposite side. है ना? So from the starting, let's say if this configuration was, let's say this configuration was R, अगर ये यहाँ पर R configuration था तो यहाँ पर ये S हो जाएगा, and this only is called inversion of configuration. Inversion of configuration मतलब अगर Cl minus will come and यहाँ पर Cl minus है, then OH minus will come from the back side. बैक साइड से आके Cl माइनस को रिमूव कर देता है ना? तो Cl माइनस को, जैसे लेट से योर ब्रदर इज देयर एंड नो वन इज एट होम एंड यू वांट टू ईट द आइसक्रीम, सो आप पीछे से चुपके से कहीं से जाते, चुपचाप डोर खोलते और आराम से अपनी आइसक्रीम लेके चले जाते और ब्रदर को पता भी नहीं लगता, ही इज आउटसाइड ओनली, ब्रदर और सिस्टर एनीवन, है ना? सो योर बॉन्ड विल बी मेड बट योर कॉन्फ़िगरेशन इज रिवर्स्ड, कॉन्फ़िगरेशन इज रिवर्स्ड, मतलब पहले आर था तो ये एस हो जाएगा, अगर एस था तो ये आर हो जाएगा, है ना? तो दिस कॉन्फ़िगरेशन विल बी स्टडी more about the stereochemistry, but our mechanism is one step concerted mechanism. इसको हम लोग क्या कहते हैं? इसको हम लोग कहते हैं one step concerted mechanism. कंसर्टेड मतलब एक साथ ही हो जाएगा बेटा, कंसर्टेड का मतलब वन स्टेप कंसर्टेड मैकेनिज्म, वन स्टेप कंसर्टेड मैकेनिज्म इट हैज with what? Backside attack, with backside attack of nucleophile in sigma anti-bonding molecular orbital of C and X. द एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल में अटैक होके यहाँ से Cl को रिमूव कर देते, है ना? सी बेटा OH माइनस इज ऑल्सो अ न्यूक्लियोफाइल एंड Cl माइनस इज ऑल्सो अ न्यूक्लियोफाइल, तो दोनों यहाँ से फ्रॉम दिस साइड इट कांट अटैक, फ्रॉम दिस साइड इट कांट अटैक बिकॉज बोथ आर नेगेटिव नेगेटिव्स, है ना? सो बोथ आर नेगेटिव्स नेगेटिव्स, सो दीज they cannot attack from this side, so he has to grow from opposite side to attack on this carbon, है ना? Write this main mechanism in your copy. Write this main mechanism. You should always know these 3 points in the mechanism, that it is a one-step concerted mechanism. The attack will occur at the back side, and it will make us what? Transition state, which is pentavalent. Which is pentavalent. So write this main reaction. Write these 3 steps after the mechanism of the reaction. Under mechanism of the reaction, write these 3 steps and we will proceed further. Chale, I will give you 2 minutes. Write this. Yes, beta, it will change the whole compound. The alkyl halide series, Thejal told the configuration of substrate will change the whole compound. Yes, beta. From alkyl halides, we are changing to alcohols. We will come to know down. I will show you. Configuration I will show you, don't worry. Just write this. So what is the transition state? Transition state is that state in which bond making and bond breaking is happening simultaneously. Bond breaking and bond making is happening simultaneously. This is known as what? Transition state. I have told you in the starting lecture also, in making energy diagrams, all those mountains are known as transition state, and all those valleys in the energy diagrams are known as what? Intermediates. You know? So we have studied in the starting class also about intermediates and transition state. So let's go further. एक और देखें. देखिए चलो. Where it is go. अच्छा ये रहा. Wait a minute. Sure. See beta here. एक. So we will try to draw the energy profile diagram of this reaction. So what will happen? This OH minus will come and will attack. So the energy of the reactants is given in this reaction. This is the reaction coordinates, how the reaction will go. This is the reactant. These are the products. So energy of this reactant which is required. And this is the activation energy. This from up to from here. This energy is known as the activation energy, free energy of activation, delta G of activation, delta G of activation. So it require 103 kilojoule per mole of energy to convert this OH minus to CH3OH. And from if it is going from here to up to transition state, you have to give energy. है ना. यहाँ पर OH माइनस को कार्बन पे अटैक करना, Cl को रिमूव करना. So this the mountain is known as the transition state. So at this position at the mountain, this bond will be breaking and this bond will be making. So when you have equal possibility on the mountain to fall this side also and fall this side also, है ना. अगर ये इधर गया तो ये OH का बॉन्ड बनेगा, Cl का टूट जाएगा, है ना. अगर ये दिस साइड गया तो यहाँ पर ये वाला बॉन्ड टूट जाएगा और कार्बन Cl का बॉन्ड इट विल मेक, है ना. सो ऑन माउंटेन यू हैव इक्वल पॉसिबिलिटी टू जंप आइदर साइड, है ना. So if I want to convert my reactant to products, I have to give 103 kilojoule of energy, और यहाँ से this energy of products will be getting, है ना. तो हमें 103 दिया यहाँ पर, तो यहाँ पर these products can easily jump from transition state to products, है ना. So this is what the energy diagram, free energy diagram for reaction of SN2 reaction. This is SN2 reaction. मतलब बैक साइड अटैक करके इसको यहाँ से निकाल देने का और हमारा काम हो जाता. समझ रहे कि नहीं? ड्रॉ दिस इन योर copies and write here free energy diagram. Free energy diagram. Draw ऐसे से draw कर लें. Don't write anything else. Write this. Write reactant, transition state and product. 2 minutes. 1 minute I am giving you. Write fast. Write reactants, transition state and product. Just write. Draw x-axis and y-axis. Write what is on x-axis, what is on y-axis. Yes, beta, meeting is locked. Beta, I can't unlock again and again. No, beta. Tejal, you will come to know. Slowly we'll go. Don't worry. Beta, if I keep it unlocked, Anyone can come and join, beta. Sir, then you beat them. I will beat you first. Today my wish is fulfilled. At least you can't even speak in front of me. I can teach whatever I want to teach and no one is able to speak. Tejal beta, you are wrong. RR won't change to RSS because you have to see that carbon only beta. वहां पर ही चेंज होगा जहां पर अटैक होगा. Then made this diagram. चले. So next thing, right? This was first SN2. This was SN2 reaction. This was the mechanism of that reaction. This is free energy diagram of that reaction. First was SN2 reaction. Then was mechanism. This is free energy diagram. Next thing we will write about the stereochemistry of SN2. Stereochemistry देखते हैं. SN2 reaction की stereochemistry कैसे होती. Let's say this carbon we have which is R. 2 ब्रोमो ऑक्टेन है ना. ये R है तो R का हमारे पास it will change to S. It will change to S. So OH minus will come and this Br and CH3 which is in the plane, this is in out of the plane, hydrogen is inside the plane. So OH minus will come attack on the carbon and remove the bromine. So this is the transition state. The transition state are shown by double daggers. है ना, ये डैगर बना के हम लोग शो करते हैं ट्रांजिशन स्टेट को. और दिस OH will come here. This CH3 which was this side will try to go in opposite side. है ना, if you do 1 2 3 here rotation, you want to see from fourth position opposite. Fourth position के opposite देखते हैं. So hydrogen is always fourth position smallest. You have to see from front. Oxygen 1, then this carbon will be 2 and this carbon will be 3. So 1 2 3 if I rotate, this is moving anti-clockwise and from forward only I am seeing this is S configuration. This is S. So from R we have changed to S. This only is the main property of SN2 reaction, which is this is the main property of SN2 reaction, which is inversion of configuration. Inversion of configuration. Always remember SN2 reaction has only one transition state. है ना, ये आपको दिखाया. Always remember in stereochemistry of SN2 reaction we have to do inversion. We have to do inversion. देखिए नीचे same example we have it is given. OH minus will come attack on carbon and Cl minus will go. This is the transition state and this is the inverted product. This is the product which we got, which is inverted. Done. समझ आ रहा है आपको ना? Write yes or no. Write yes or no in the chat. Who is writing this all? Beta here no carbocation is made, nothing it is made. Directly attack on carbon, remove another one. है ना, nothing. Mechanism क्या होता? OH minus will come attack on carbon and remove the Cl minus. So any nucleophile can come. Any nucleophile can come and attack on carbon to remove Cl minus. समझ रहे कि नहीं आप? Simple hai, nothing bit difficult it is. So write these two things, stereochemistry of SN2 reaction, write this reaction in your copy and write inversion of configuration. These two things write. Don't write this. Don't write this. I am cutting this beta. Don't write this. Just write it is R, it is changing to S. R is changing to S, right? This reaction, right? Don't write the line, anything, don't write, don't make diagrams, nothing you have to make. Nothing you have to make, beta. Similarly, down also write the reaction, write the inversion of configuration. These only two things, right? Fast. I'm giving you time. लिख लिया आपने? बताएं. चल. We'll start next thing, beta. Next thing, see, if I have an alkyl halide, I want to convert my alkyl halide to another groups, to another functional group. So what I can do, I can always do SN2 reaction. And this SN2 reaction is used for functional group transformation. Functional group transformation. Done. So I can change from alkyl halides. I can change from alkyl halides to alcohol, ether, thiol, thioester, nitrile, alkynes, ester, quaternary ammonium halide, allyl azide. है ना? These all examples you can take. In nitrile also there are two examples I will tell you. So one by one we will do. So these all are nucleophiles. They are attacking on the carbon of the allyl. They will go and attack. They will go and attack on the carbon to remove X minus. To remove X minus and from here. So first OH minus goes and attack. It will make alcohol. RO minus alkoxide. इसको कैसे कहते हैं? Let's say we have alkoxide, है ना? Let's say we have RO minus Na positive alkoxide. R can be anything. It can be benzene or it can be CH3, anything it can be. So I can make ether from alkyl halide adding RO minus Na positive. Next is SH minus. So I can make thiol. These are known as thiol. SH is known as thiol. If I have S minus R, it is known as thioether. है ना? If you have oxygen, both side carbon, it is known as ether. If you have sulfur, both side carbon, it is known as thioether. है ना? Similarly, if we take Cn minus, it will attack on carbon, remove X minus, it will give us nitriles. Nitriles, Cn minus. Example here you can write KCN. KCN, right? KCN if I add, it will make RCN. Similarly, here only write if I add AgCN. If I add AgCN, it will make RNC. And it will make RNC. It is known as isocyanate. RNC इसको लिखें isocyanate नहीं, isocyanite. Just a minute. If I add here, if I add AgCN, it will make RNC. If I add KCN, it will make RCN. This is very important. I will tell you the reason of this also. है ना? लिख लें. Last thing, if I add this alkyne group here, it will attack on R and it will remove X to make alkynes. है ना? So let's say we take R triple bond C negative Na positive. अगर ये लिया तो यहाँ पर ये करता. Let's say I take here any CH3COO K positive or Ag positive. है ना? Silver salt of carboxylic acid. Yesterday we have studied in Hunsdiker reaction. Silver salt of carboxylic acid or potassium salt of carboxylic acid. If I attack, this OS minus will attack on R group and X minus will remove to give me ester. Similarly, R3N, if I attack from here on carbon, it will give me quaternary ammonium halide. इसको कहते हैं quaternary, 4 carbon with nitrogen, 1 3 here and 1 here, 4 carbon with nitrogen, quaternary ammonium है. Similarly, N3 minus, इसको हम लोग azide कहते हैं. N3 minus will go and attack. N3 minus will go and attack to give us azides. Alkyl azides, to give us alkyl azides. So this is very important for functional group transformation. These all in between which you have seen, these all are nucleophiles. These all are nucleophiles which are attacking on these all are nucleophiles which are attacking on carbon substrate to remove which leaving group? Excess leaving group. So leaving group can be chlorine, bromine, iodine, and R can be methyl 1 degree or 2 degree. है ना? 3 डिग्री में नहीं, 1 डिग्री और 2 डिग्री में और मिथाइल में. ओनली इन दैट यू हैव टू चेक. है ना? सो राइट दिस इन योर कॉपी, राइट ड्रॉ लाइक अ ब्यूटीफुल टेबल एंड देन वी विल प्रोसीड फर्दर. जल्दी जल्दी लिख लें बेटा. This list I can increase further beta. Let's say we have R2CuLi, है ना? So you can make from here CH3. You can make what from here? If you have R2CuLi here, if you have R2CuLi here, the nucleophile is R minus. R minus will go attack the carbon here and remove. So R will be made. This R and this R will be made. Let's say other example also. R2CuLi is known as what? It is known as Gilman reagent. Gilman reagent. और इसके रिएक्शन को हम कहते हैं कोरी हाउस सिंथेसिस. You might have studied in alkane chapter, Corey house synthesis. Last one I am writing, if I add RMgX in this reaction, which is known as what? Grignard reagent. Grignard reagent. If I am adding Grignard reagent in this reaction, similarly here the nucleophile is R minus and Mg positive. R minus is the nucleophile. R minus will go and attack on the, this R minus will go attack and on the R, and X minus will be removed. So product will be RR. Simple it is. There are huge list. Lithium aluminium hydride. Here nucleophile is hydrogen, you will get RH. RH. Write this in your notes. Beta, how we got order to, you will come to know better when you will study chemical kinetics. How fast and slow the reaction is occurring, we can calculate that by the order, by writing the rate of the reaction. And Puneet, we will come to know the order by writing the chemical reaction rate. See beta, in chemistry, every reaction we can calculate the rate, how fast it is going, how slow it is going, है ना, धीरे या तेज जा रही है. And we can also calculate the stability of reactants and stability of products, है ना, by calculating the energy of reactant and energy of product. So always any substrate will try to decrease the energy. कोई भी क्या करता है, अपनी एनर्जी को डिक्रीज करता. इफ इट इज डिक्रीजिंग द एनर्जी मोर, अगर एनर्जी उसका मोर डिक्रीज हुआ, सो इट विल बी मोर स्टेबल, है ना. डोंट वरी, विल. सर, what is found when we add AgCN? Beta, when we add AgCN, isocyanides are formed, beta. When we add AgCN, where it is written? Huh. When we add AgCN, isocyanide कहते, RNC बनता. Similarly, if I here also, if I add KNO2, if I add AgNO2, so here what will form? RNO2 will be formed, not RONO. याद रखें, this is too important. AgNO2, KNO2, and AgCN and KCN. These two are more important, beta. AgCN and KCN. So write this beta in your copies, right? Don't worry, if you are not getting time, after the class only I will share you the notes. Just take 5-10 minutes and write all the things which are required. Don't worry if you are lagging behind, if you have not written, don't worry at all. Sure. 1 minute more I will give you. Next we will start. In the last, I will unmute you. Sir, which reagent will give us this? Isocyanide will be given by AgCN. Silver cyanide. Isocyanide will be given by silver cyanide. Done? चलो then with the last thing I am writing today, see beta factors affecting, last thing we will write, factors affecting SN2 reaction. Which are the factors which will affect the SN2 reaction? So let's say I write one SN2 reaction, एक SN2 लिखता हूँ, उसमें बताता हूँ आपको कौन कौन से factors will affect. Let's say we are taking this Br, we have here a nucleophile which is OH minus. This OH minus will attack on carbon, Br negative will go, making a transition state in between. You all know the mechanism now. ये यहाँ से आएगा, यहाँ से धीरे 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 ये वाला बॉन्ड टूटेगा और ये वाला बॉन्ड यहाँ पर बन जाएगा. So OH will be made this side and ये यहाँ पर बना और Br minus will be. So first factor is which will affect will be the effect of substrate, will be the effect of substrate, this effect. अगर ये छोटा हुआ या बड़ा हुआ, so that will affect the rate of this reaction. So let's say substrate we take here, let's say simple alkyl halide अगर हम लें CH3X, let's say CH3X लें, and if I take 1 degree Rx, if I take 2 degree alkyl halide, or if I take 3 degree alkyl halide, है ना? So in all the four in which the attack, backside attack is more favorable will be the CH3X than 1 degree than 2 degree. Because beta in 3 degree alkyl halide, if I have this carbon, this, if I need to attack OH minus in 3 degree alkyl halide, here the thing which happens is known as steric hindrance. Steric hindrance. So this attack it won't go. ये अटैक नहीं कर पाता बिकॉज दिस कार्बन विल हैविंग इट्स ओन हाइड्रोजन्स हाइड्रोजन्स हाइड्रोजन. सो यहाँ पर ये अटैक नहीं कर पाता इन रिस्पेक्ट टू 2 डिग्री, इन रिस्पेक्ट टू 1 डिग्री एंड रिस्पेक्ट टू सिंपल कार्बन. So simply if I have this hydrogens, all hydrogens, so hydrogen is the smallest atom, OH minus can come and take its electron and donates its electron to sigma bonding easily in simple alkyl halide. But if I have 1 degree alkyl halide, means if I have this CH3 here, one hydrogen, hydrogen X, so here possibility will be little less, here possibility more less, and in 3 degree it won't go for SN2 reaction. So always remember 3 degree Rx won't show SN2, no SN2 reaction they will show. But 1 degree will be the our first priority to show us the 1 degree, and simple CH3X will be our first priority to give us the SN2 reaction. Then so always remember in SN2 reaction, we always try to see what the steric hindrance. Steric hindrance. We will also always try to see steric hindrance on what? On substrate. Substrate के ऊपर steric hindrance देखना. अगर ज़्यादा लोग हैं तो अटैक नहीं कर सकते, कम लोग हैं तो हम अटैक कर सकते हैं भाई. सिंपल इट इज. आपके घर ज़्यादा लोग आ गए हैं तो आप ज़्यादा बातें मत करें, चुपचाप शांति से बैठें. ज़्यादा लोगों से बातें ज़्यादा करोगे तो फिर आपसे वो ज़्यादा क्वेश्चन पूछेंगे, है ना. अगर आपके घर लेट से एक लोग आए हैं, लेट से एक मेहमान आए हैं कोई है, थोड़ा बहुत आप बातें कर सकते हैं बस. डायरेक्टली यू कैन अटैक एंड यू कैन रिमूव द एग्स. पर आपके घर एकदम से जॉइंट फैमिली आ गई, आप भी परेशान हो गए, क्या करें भाई, इतने सारे लोग बैठे हैं, मैं कैसे जाके बात करूं उनसे. नहीं कर सकते आप भाई. So SN2 reaction depends upon the steric hindrance of substrate. Second thing we will try to see, it depends on substrate. Second thing is depends upon the leaving group also. अगर कोई अटैक कर रहा है पर लीविंग ग्रुप कह ही नहीं रहा. Leaving group is saying I don't want to leave. I don't want to leave. So how can this be attacked with? है ना? So dependence on leaving group also. So leaving group will be such that कि it directly attack हुए और leaving group directly it will remove easily. You can remove the leaving group easily. In that SN2 reaction will be more favored. है ना? So let's say second also leaving group, if I tell you, it depends upon leaving group also. Let's say I have RI. R क्यों लिखें? सिंपल वाला लिख लें हम. Let's say I have CH3I, CH3Br, CH3 chloro, and CH3 fluoro. And all these in all these I put aqueous KOH. Always remember aqueous KOH में हमेशा हमारे पास SN2 reaction होगा. अगर SN2 reaction होगा, see this OH minus will come and attack from back side. This OH minus will come and attack from back side. अगर ये यहाँ से बैक साइड अटैक करके जाता, ज़्यादा बड़ा हो गया. अगर ये यहाँ से इसके बैक साइड अटैक करके जाएगा और I माइनस को निकालेगा, आउट ऑफ फ्लोरो क्लोरो ब्रोमो आयोडो विच वन विल रिमूव फास्ट? दैट यू हैव टू टेल. विच वन इज गुड लीविंग ग्रुप? Out of fluoro chloro bromo and iodo, which one is good leaving group? You have to tell. Simple. Think about it. So which one reaction will be more fast? I have given you 4 reaction with this iodomethane, bromomethane, chloromethane and fluoromethane. I put aqueous KOH. In which of the following leaving group will leave fast? Write your answer in the chat box. Will it be fluoro or will it be iodo? कौन सा पहले भाग जाएगा? Which one will be the first leaving group? So see beta, from here only you will come to know that I minus is the best leaving group and fluorine minus is worst leaving group. See from here, from going up to down, size is decreasing. If size is decreasing, so if this is bigger size, if I want to bigger size means bond strength between C and X, from up to down it is increasing. इसका bond length, इसका bond strength very strong. Small it is strong. This one bond strength very weak because bond length is very big. बॉन्ड लेंथ बड़ा है इसका बॉन्ड लेंथ बड़ा है तो इसका बॉन्ड स्ट्रेंथ बहुत वीक है. एवरीवन नोस, है ना? तो अगर ये बॉन्ड वीक है तो इट कैन गो इजीली. सो I माइनस विल बी द बेस्ट लीविंग ग्रुप and F minus will be the worst leaving. So out of all the 4, which one will react fast? CH3I will react fast, then CH3Br, then CH3Cl, and the last will be CH3L. This is about the reactivity. This is about the reactivity. Done? Sure. Very good answer you have told. I minus will remove. So out of all the 4, I minus is the better leaving group, then Br minus, then Cl minus, then fluorine minus. This is what leaving groups. Leaving group कौन सा ज्यादा है कौन सा कम? Simple it is. चलो. So one question only you have to solve. Write this all. 1 minute I am giving you, write this. Now we will do questions. One question solve. These are two factors. One is the steric hindrance, other is the leaving group. Two more factors are left. With this, our class today will be over. 1-2 questions we will solve, and then you can enjoy your lunch today. Chale. Write fast, beta. Don't worry. I will give you the time to write. Question here, see. Which of the following will fast SN2 reaction? In which of the following which you will have fast SN2? So first one, let's say I have here this one or this one. इन दोनों में से किस में होता फास्ट? You have to tell A or B. Second one I am writing here bromine or here. Third one C. So 1, 2, 3. This is A, B. You can write answer. You can write answer 1A, 2A, 3A or 1B, 2A, 3B. Write this. Tell me the answer. Two things you have to see. First thing is the leaving group. है If substrate is same, first you have to see the substrate. If substrate is same, then go to the leaving group. If leaving group is same, you have to check the substrate. You have to check the substrate. है So out of chloro, first answer, let's say first one is which answer out of chloro and bromo, which one will leave fast? Bromo will leave fast because it has a bigger size, it can leave fast. If OH minus is attacking in SN2 reaction between chloro and bromo, bromo will leave fast because bromo is a bigger size. So first one answer will be B. Second one answer check. Second one answer, this is 2 degree alkyl halide, this is 1 degree alkyl halide. So always remember you have to see steric hindrance in substrate. Both we have bromine, so it has same leaving group. So it depends upon what substrate. This carbon is attached to 2 carbons, therefore 2 degree alkyl halide. This carbon is attached to only 1 carbon, so therefore 1 degree. तो यहाँ पर अगर अटैक करते, it will be more easy. And here if you attack, it will be more difficult because it is 2 degree, more steric hindrance. So in second, 1 and between A and B will be our answer. Third one also check, tell. Third one also tell. See, in both the cases we have bromine. So bromine leaving group is same. So now it depends upon substrate. So this substrate, both we have benzene ring, both have benzene rings. This side, and this carbon on which bromine is attached, it is 1 degree carbon. This carbon is 2 degree carbon. Always remember on 1 degree it is more favorable, SN2 more favorable on 1 degree or simple carbon due to steric hindrance. So out of 3, third one answer will be A. So OH minus can attack here more good, and here it is more difficult to attack. डन? सबको समझ आया? सबको समझ आया बेटा? यस, सिंपल इट इज, वेरी सिंपल इट इज बेटा. कुछ नहीं देखना है, लीविंग ग्रुप देखना है, और सबस्ट्रेट देखना है, स्टेरिक हिंड्रेंस देखना है, क्योंकि अगर अटैक करते हैं, अगर वहां पर कम लोग हैं, less people are there, you can attack easily. But if they have many people, many steric hindrance is what? No one is allowing you to go inside. वहां पर अटैक, जैसे आप बाहर से आपको अंदर ही नहीं जाने दे रहे हैं. That is called steric hindrance. Let's say yesterday I went to see a movie, and outside theater only there were many people. Outside 100 people sitting outside theater for the movie ticket. So that is all what? That is all what? It is all steric hindrance. वो मेरे के लिए hindrance they have created going inside only. है ना? If there is no hindrance, no one is there. Let's say movie is simple movie, no one is going to see. And if I want to see, I can go easily and I can see. है ना? चले. So with this, or these two factors are over, factors affecting SN2 reactions. Next thing is, third factor is nucleophiles. Strength of nucleophiles, you can write nucleophile concentration and strength. This also will be the factor. So this OH minus will also be a factor. This OH minus which is attacking, this attack should be strong. Strong people should go and attack. अगर मैं ही, let's say मैं ही छोटा पतला सा हूँ, छोटा baby is going inside, तो the attack will be very less. If someone bodybuilder is there and there are many steric hindrances, but the man is there with body and he can go and attack and easily, है ना? So same way, in this also, the nucleophile concentration should be strong and strength should be strong for SN2 reaction. This all we will see. है ना? And nucleophile concentration and strength we will know by its nucleophile के पास होता one property which is known as nucleophilicity. Nucleophilicity. This nucleophilicity is the property of nucleophile. This is the property of nucleophile to attack on carbon. This is the property of nucleophiles to attack on carbon. So now we will come to know which nucleophiles are strong, which nucleophiles are weak, and which is a nucleophile and which is a base. Nucleophile कौन सा है और base कौन सा है, will come to know. चल. So let's say we take an example CH4, ammonia, H2O and HF. है ना? So we are changing carbon, nitrogen, oxygen and fluorine. From here to here, if I go, electronegativity of the center atom, is increasing from carbon to fluorine. If electronegativity of the center atom is increasing, so what will happen? Its acidity will increase, beta. Acidity will increase. Because electronegativity क्या करता सेंट्रल एटम का, all electrons fluorine wants on himself. He wants to take electrons of hydrogen all. So if he has taken all the electrons, H positive can easily release. है ना? And here electronegativity weak electronegative, है ना? So ये तो अपने आप को सारे electrons नहीं ले सकता, therefore it is less acidic. He can't give H positive to us. है ना? Similarly, if he has given, let's say, if he has given this, he has given H positive, he has given H positive, he has given H positive, and he has. So out of these four, fluorine minus is more stable. More stable means more electronegative. He can take electrons on himself easily. Electrons he can take himself on easily. OH minus can take electrons easily on himself. This NH2 minus and CH minus can't take electrons, therefore they act as bases. They act as bases. है ना? From here to here, ये दोनों CH minus and N minus. Always remember, whenever you have N minus, they will act as bases. They will act as bases. है ना? And whenever you have carbon minus, they will act as bases. But if you have OH minus and fluorine minus, they fluorine minus, chlorine minus, bromine minus, iodine minus, these all will act as nucleophiles. These all will act as nucleophiles. है ना? Always remember these nucleophilicity कैसे बढ़ रही है ना? So we will understand which one is more nucleophile, which one is less nucleophile by nucleophilicity. Nucleophilicity. So first one, let's say CH3 minus. Next we have NH2 minus. Next we have OH minus. Down we have SH minus. Here we have fluoro, chloro, bromo. From here to here, in this trend, nucleophilicity will increase. ये ट्रेंड है, याद रखें इसका ट्रेंड को, है ना? So this is the order of nucleophile, which nucleophile is strong, which nucleophile is weak. देखें. So this order you have to remember of nucleophiles. Order, remember, let's say we have CH3S minus, sulfur. Always remember sulfurs are always good nucleophiles. Then we have I minus, then we have C minus, then we have CH2O minus, then we have bromine minus, then we have ammonia, chlorine, fluorine, last is CH3OH. So this order always remember, beta. Order of nucleophilicity. Order of nucleophilicity, always remember. This order will always tell you which one will attack fast. Which one will attack fast. So let's say I have CH3, any group, let's say leaving group बना दें OH2 positive. नहीं ये वाला नहीं. Wait. है ना? देखें, let's say. So let's say we have CH3 and here I have any leaving group. So and this are our nucleophiles. So इनमें से कौन सा वाला सबसे ज्यादा अटैक करके कार्बन पे लीविंग ग्रुप को निकाल सकता? First one will be CH3, S minus, then I minus, then Cn minus, then CH3O minus, then Br minus, then ammonia, chlorine, fluorine, and CH3O. This you should remember the order. See one example, beautiful thing I am telling you. देखें. Don't worry, you will be, this all will be shared. Don't worry. Just listen to me now only. Let's say we have this hydrogen. Let's say this. This is one alkyl halide and this one is one alkyl halide. देखें. See what happens अगर यहाँ पर let's say I have iodine minus which is coming and attacking on carbon. And we have fluorine minus which is small size fluorine and goes and attacks on the anti-bonding sigma antibond. है ना? Because from here you all know, because iodine minus is bigger in size than fluorine minus, and polarizability you have learned in Fajan rule that polarizability of iodine minus is more than fluorine minus. So क्योंकि ये बड़ा है तो यहाँ से अगर ये जाएगा यहाँ पर, so it can go fast than fluorine minus. So it can go fast than fluorine minus. इसको यहाँ जाने में इसको steric hindrance का पूरा, he has to cover the steric hindrance other things also. है ना? In this you have no steric hindrance because hydrogen is very less. But if fluorine minus is very small, अगर कोई बड़े को लेके जा रहे हैं और यहाँ पर एक छोटी सी चीज है, from far only he can put hand. है ना? Let's say I am very tall. Let's say I am 6 foot. है ना? From above only I can take the things which is kept in the kitchen. है ना? And let's say when small boy is there, my small brother or my small sister is there, so she will do like this. अरे यार क्या करूँ मैं, इसको कैसे लूँ? And how can I pick? How can I attack on carbon? है ना? So fluorine minus, from here only you will come to know that iodine minus is more good a nucleophile with respect to fluorine minus. And this only is dependent upon, so this nucleophilicity is solvent dependent. This nucleophilicity is solvent dependent. मतलब अगर मेरे को यहाँ से यहाँ पर अटैक करना है, इसके बीच में जो सॉल्वेंट मॉलिक्यूल्स हैं, जो सॉल्वेंट मॉलिक्यूल्स विच आर प्रेजेंट इन बिटवीन देम, दे ओनली विल डिसाइड कि कौन सा अटैक जल्दी कराना है और कौन सा अटैक लेट कराना है ना? सो दिस वी विल लर्न सून कि हम लोग देखते, लेट्स से टुडे ओनली राइट दिस टुडे, नेक्स्ट क्लास आई विल टीच यू अगेन, डोंट वरी. Let's say we have chlorine, bromine, iodine, and yeah. So see, from going up to down, size is increasing. Size is increasing. up से नीचे जाते हैं तो साइज इंक्रीज हो रहा है, और डाउन से आप ऊपर जा रहे हैं, बेसिसिटी इंक्रीज हो रही है बेटा. यहाँ से बेसिसिटी इंक्रीज हो रही है. सो यू ऑल नो दैट fluorine minus chlorine bromine, iodine minus will be more good nucleophile because it's a bigger size, it can attack easily, enough. So iodine minus, you know that nucleophilicity will be more in polar protic solvents beta. Polar protic solvents. Example, if I take, let's say we have water, alcohols, है ना, और हमारे पास दूसरे वाले जैसे अल्कोहल में भी वी हैव इथेनॉल, वी हैव मिथेनॉल एंड इथेनॉल्स. So all those which are polar in nature and which are protic मतलब they can give H positive. So from up to down, in this nucleophilicity order will be that fluorine in this polar protic solvents, fluorine minus से ज़्यादा, chlorine minus से ज़्यादा, bromine minus से ज़्यादा, iodine minus. So iodine minus is the winner in polar protic solvent for nucleophile. This you remember better always. Iodine minus is the winner. He is more nucleophile. He is more nucleophilicity in polar protic solvents. But always remember this order will reverse in nucleophiles, nucleophilicity in apolar, in wait. This order will reverse in polar aprotic solvents. Polar aprotic solvents. Example of polar aprotic solvents are DMF, DMSO, DMF, DMSO, DMF, DMSO, or THF. DMF is dimethyl formamide, dimethyl formamide. DMSO is dimethyl sulfoxide, dimethyl sulfoxide, and THF is tetrahydrofuran, 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 है ना? Always remember beta. So nucleophilicity order will change. This nucleophilicity order will change in, this nucleophilicity order depends upon solvents. This nucleophilicity order depends upon solvents. In polar protic solvents, iodine minus will be stronger. But in polar aprotic solvents, fluorine minus will be stronger than chlorine minus, than bromine minus. This is our main thing of today's class, that nucleophilicity will be depending upon solvent. And why this is dependent, leave on me. I will tell you. Why this is dependent, leave on me, I will tell you. है ना? Why this is dependent, leave on me. Next class we will discuss in detail. अच्छे से पढ़ेंगे, है ना? This was our third topic. Fourth topic, right? Fourth topic, last factor which we will study today is the steric factor of nucleophile. अगर let's say जो nucleophile who is attacking on carbon and he is removing the X, this nucleophile is very big, very big. अगर यही बहुत ज़्यादा बड़ा हो गया, so it can't attack, it can't go, it will become lazy, it will become lazy. So let's say we take two example. ये है एक nucleophile, this one, it is attacking on CH3Br, and let's say we have tertiary, ये वाला tertiary butoxide, tertiary but ऑक्साइड, इसको क्या कहते हैं? टर्शरी ब्यूट ऑक्साइड, 3 डिग्री. इफ इट इज अटैकिंग ऑन दिस कार्बन, सो इट कांट डू SN2 रिएक्शन, ये नहीं कर सकता, बट इट कैन डू बेटर बिकॉज इट इटसेल्फ इज स्मॉल. So the steric on the steric factors, the size of the nucleophile also, size of the nucleophile will also tell us the reaction will go or not. है ना? Size of the nucleophile will also decide SN2 reaction. है ना? So always these things are more, which are the main factors of SN2 reaction. Today last thing, summary we will try to see of SN2, and with this our today's class will be over. देखते हैं. Just 1 minute, give me more. One minute today, see. So today in our class we have considered the conditions for SN2 should be what? That the leaving group, it should be what? It should have unhindered leaving group. है ना? Unhindered leaving group होना चाहिए. The order of reactivity, you should always see here the steric hindrance. You should always see the steric hindrance, in which you have very less steric hindrance. In that the order will be, the reaction rate will be very fast, है ना? So order will be very fast in methyl, then 1 degree, then 2 degree, 3 degree में नहीं होता directly. Tertiary halides do not react by SN2 mechanism. SN2 से नहीं करते tertiary halide, 3 degree alkyl halides. We always need a strong nucleophile, है ना? Usually negatively charged. Always remember, negatively charged are more stronger nucleophiles than simple nucleophiles. We always require high concentration of nucleophile. Nucleophile का concentration excess में लेना, then only you can get SN2 reaction. We always need a polar aprotic solvent. The solvent effect I will teach you in next class. We always need a polar aprotic solvent. Last is dependent upon leaving group. Ri में सबसे ज़्यादा leaving group है, then RBr, then RCl. Ri, if you attack on R iodo, I minus can easily go, then Br, then Cl. Because alkyl fluorides react so slowly, they are seldom used in nuclear. So alkyl fluorides तो बहुत धीरे करते हैं. फ्लोरीन का बॉन्ड तोड़ना बड़ा मुश्किल है. आयोडीन का बॉन्ड तोड़ना very easy, very big iodine it is, है ना? So if someone wants to remove leaving group iodine, he can easily remove. But फ्लोरीन को नहीं नक्को करना भैया, फ्लोरीन को कभी नहीं करना, क्योंकि फ्लोरीन तो वैसे ही बड़ी स्मॉल है, बड़ी प्यारी है, उसको अपने पास ही रखो, बैठा के रखो अपने पास. Done. With this beta, our today's lecture we are going to end. If you have any doubt, you can unmute yourself and you can ask.